Great, thanks for that, Hamid. So let's kick things off. I think we've got a couple of people here, and there might be a few more that might join along the way, which would be great. So welcome to Data Engineering Melbourne. Um, Obviously, this is the November presentation. I'll sort of preface with a quick little note, which is we actually won't do a December presentation. We think a lot of people are generally on holidays, and particularly in Melbourne. Uh, because we're now out of lockdown, there are a lot of people that are very busy at the moment, traveling around and going places and doing things. So we actually won't do won't do a December presentation. Um, but yeah, there will be a January one, and we look forward to kicking off next year. So this will be the grand finale presentation for 2021, which is really good. So we'll do a quick intro for Harshith, who's presenting today, and he's going to talk to us a little bit about AirByte. And as we normally do each month, we'll also do our community marketplace. So that's a great opportunity after the presentation to unmute yourself and tell everybody a little bit about an opportunity you might have and you're looking for data engineers to come and help you on a project or in your business. Or if you're a student or a professional person and you're looking for an opportunity and looking for some work, then we'll give you a minute to introduce yourself and tell people what sort of work you're looking for and interested in to see if there's anyone that can help. In the marketplace, we also like to provide the opportunity for anyone to talk about any open source tools or technologies or projects people might have or be working on or have an interest in, things like AirByte. Because if you're interested in the project, there's a good chance that others will be interested in the same project as well. And it might be something that we could organise a talk on or talk to people about and stuff, which is good for everyone. So without further ado, I'll hand over to Harshith, who's going to talk to us from AirByte. I think Harshith has been working for AirByte just this year. He's joined. And really excited to learn a little bit about what AirByte is and how it works and what it does. So with that, I'll hand over to you and you can share your screen if you've got some slides or something you wanted to start with.
Yeah, thanks, Tim. Thanks for the intro. Um, I think I really get the feeling all of you guys have of not knowing AirByte. I was also in the same state a couple of months back, start of this year. But yeah, it has been a pretty great journey, being a contributor and then getting into AirByte. Has been such a good experience, and I think this is one of the tools which we are looking in open source, which is um, quite a mesmerizing product where we don't really had any more, probably more kind of open source tools like this. Meltano was one in terms of ETL space, and then AirByte comes it, and probably I think it's ruling right now because of a bunch of standards which are in place and a couple of things which really did work out, and of course the team. So I think we'll have very good, probably a good understanding by end of this, the whole presentation. There's also a certain demo which we'll also look at by end of this and probably do it continuously as we go. Okay, myself Harshith. I work as a success engineer here at AirByte. So for me, the goal is to ensure that every person who comes into AirByte is happy in terms of deployment and also his work. Being a tech guy and also an entrepreneur, I had a couple of startups before this. I love traveling. That's most of my time that I'm not in front of the keyboard. I just travel someplace. Um, I think pretty much that's it. Yeah. So we'll get started. So just a small short intro on what AirByte is. So it's basically an open source tool which is runs the ETL data pipelines. So we have something called sources, and then we have something called destinations, and we basically connect these both so the data travels from source to destination. So I think pretty much that's the product. That's where the whole thing evolves. So that's where we have been working for quite some time. There are a bunch of plans on streams and a couple of other data pipelines which is gonna kick in next year. But right now our major focus is on ELT pipelines. Um, this is a short story you can get on AirByte. Though we had funding, I'm just not putting all of those details here, but just more of what is that we look at. So we understand that every company is a data company. So uh, I think in a short span of last 6 to 7 years, the data has seen a massive growth, which has not been seen ever since in the last probably 4 or 5 decades. So we have the amount of data which grows in like 2 months is the amount of data which we have seen in the last 10 decades. Sorry, last 1 decade. So that's the amount of data we are seeing, the growth of data which we are seeing. So we also figured out that there is a problem in terms of managing it. We have to move data from a bunch of places, probably in terms of analysis or in terms of analytics and like whatnot, the multiple use cases which we have. So we want to support it in that space where we want to move data across and keep it in a standard format and don't probably mess it up anyway. Okay, this is the first time we're gonna meet here, right? So, I mean, this was my expression when I was meeting it for the first time. Because after reading all the talk, it just felt, wow, there's something new which is gonna come in, and so yeah. I'll dive more deep into tech in terms of more what happens internally. That always kept me curious. So I feel that's what everyone is more curious about. So I just kept it as simple as possible. But probably going in deep with everything may not be uh, probably 1.5 hours is not sufficient. But I tried keeping those key pieces. So we'll walk through some of those key boxes. One is worker, which plays a very crucial role in how things happen. Um, and there is a CDK, which I'll talk at the end. So these are the two key things I've picked. Reason being, they are easy to get in if someone wants to get into AirByte open source. Easy to code when someone wants to start it. So I thought that would be a right place where we can start in terms of tech. So we also have probably some app which can help us. Um, so AirByte is pretty much has, I think,
Oh no, it looks like he's frozen.
Yeah. I think today is the day where everything is going to happen.
Technical problems.
Yeah. Let's wait for some time. Maybe his internet is.
This gives me a minute to read the diagram he's got and try and understand all these pieces. And then when he comes back, he can explain them and I'll see if I was right.
Maybe there's something wrong with AWS.
Oh, he's dropped off completely.
Yeah.
Hopefully he can rejoin.
Yeah.
Well, whilst we're waiting for him to rejoin, I was going to add, please use the chat window as well if you've got questions that come up along the way and you want to know who started AirByte or when AirByte started or how big is AirByte and how many people are using it. All the questions you have, we can use the chat window, we can put them in there and we can ask Harshith to try and address some of those specifically as we go throughout the presentation.
Is it open source? Did he mention is it open source? Yeah.
Yes, it is actually, which is really good. I sort of, from what I understand at the moment, it's positioned a little bit like some of those other things like Singer is another similar tool, and there are commercial versions of that like Stitch Data and Fivetran and used to be Illuma, all those sorts of services. So it's, as I understand, it's currently pitched to do a similar thing to that, but also a little bit different, and it's open source. So I believe we can download this from the AirByte website and host it and run it ourselves. I got as far as downloading and running it, and then I got distracted, so I haven't used it in anger yet, but looking forward to do a bit more with it soon.
Yeah, I haven't even got a chance to try Fivetran as well. There have been so many tools in the market, isn't it?
Yeah, yep. I think for me, or my limited experience, there was a lot of value in some of these tools over building your own custom connectors. In an organization I was working, they wanted to be able to harvest all their CRM data. And so the question was, do we go and manually write and support and maintain our own connectors to the Zendesk API or the Salesforce API? And those APIs do change and evolve over time. And the answer was no, we didn't want to invest a lot of effort and energy in that, which is why we looked at some of these other tools. And I think that's where some of this stuff is really exciting. And you're back.
Yeah,
Welcome.
I'm really sorry.
That's okay.
Here. Yeah, getting back to
We got up to the picture, the big diagram, and you were explaining it to us. Great,
so
thanks.
I think there are two key pieces here. One is scheduler, and Temple is an external service we use to orchestrate how the syncs happen. So just to give probably a quick overview on how things happen, as we already saw, we create sources, we create destinations, and we want to connect. So the part which how the data is being transferred is all this space in between the UI and the destination. So the source and destination, whatever happens, is basically taken care by two of the main servers. One is we have a microservice called server, and then we have a microservice called scheduler. So what these two do is server basically takes care of the config API and config store. It helps us store the configurations of all the sources and destinations in terms of credentials and the settings you want to have, probably something like start date, which type of sync you want to run, when do you want to run, how frequent you want to run. So more on the config detail. And we have scheduler, which basically takes care of initiating the sync based on the time you have set, or if you want to do a manual initiation. And it basically owns the whole run of the sync, as in to initiate the sync, to transfer the data to destination, to make sure that data is whatever data is transferred, we process it, send it back in terms of till where we are pulled, to the state, or to which date we have pulled, anything of that sort, where you want to connect, save the details back on the sync, is basically taking care of a scheduler and push back to our storage. So these two pieces, the config API and scheduler, basically act as, even though scheduler is not directly exposed to the user, but those both are the places where the person who is basically connecting with the AirByte is going to talk to. There is one good piece called worker. Okay, so I think just before going there, this is pretty much a textual format of what we do. So web app server is basically the one which I'm talking about, as you have the UI basically saying back how many of the connections are there, and the what do you say, the page initial stuff. It's more or less just an API to help you understand or talk to the AirByte. So config storage is all where we storage the configs of the sources and the destinations in terms of frequency. That means when you want to run, how frequent you want to run. Any of those settings which we show in the UI are basically stored using the config storage. Scheduler store, ideally these both were different. The reason is we wanted it to be more discrete in terms of understanding, but end of the day, these both are stored in the same DB, both the config store and scheduler store. But the key difference is that, as I already said, the scheduler holds the responsibility of running the job. So scheduler only stores the status of the job and the job details, but nothing related to the source or destination. So this gives us the comfort of keeping decoupled, because we didn't want to go into the scheduler doesn't need any of the data of the source or destination. All it needs is basically the job details, and it's going to run the job. So the scheduler basically takes work requests from the API. As I said, the web server is going to request scheduler, and it basically triggers the job and ensures whether it's successful or failure, gets the data back, whether it's successful or failure, back to the server, and the server sends you back to the place where you want. We have something called Webhook to basically know that whether the job is successful or failure. So that is taking care of a scheduler in understanding whether it is success or failure, but the API server basically sends you back to the webhook. Temporal service is something which we don't really manage on our end. This is something which is more or less an available package, which was working pretty good for us, and we just want that to be used rather than building it from scratch. So we just make use of it to basically create a queue for all these tasks, and it's more or less orchestration of how the job's run and how the queue happens and how the scheduler wanted to run. All this is taken care by temporal, and we don't do any custom thing. We just use whatever temporal is available. So I'm probably not going deep in there in terms of what happens internally. But if I have any question there at the end, probably I'll be happy to answer that. I think, yeah, probably to make it more, all of this look good. Anyone has anything here in terms of any piece which you want me to go deep in?
I just had one question.
Yeah.
The temporal service you mentioned that manages the task queue, is that pluggable? And forgive me for the comparison, but if I'm thinking about products and tools like Apache Airflow and things where you're able to use different task managers or task executors like Celery and those sorts of frameworks, or is it really just a fixed thing that AirByte have configured and are using this library that does a pretty good job, as you said?
Yeah, I think that there was obviously a lot of discussion there, and we really want to support different types of task managers. But right now, temporal is quite fixed because we want it to be more production ready before we want to have more features there. So
Sure.
it just does the job. So we don't want to mess something.
Okay. Yeah, that's fine. Thanks. Any other questions? I don't think so. So
yeah, great. We don't have a massive tech stack. It's quite simple. It's either Java or Python. We don't have anything else. So the Python comes in terms of connector. So we use Python more in connector. Reason being that it gave us the comfort of not writing or reducing the amount of code we want to write, where in Java we had to write a lot of code just to make things like object-oriented running. Though it's object-oriented, we were writing a lot of classes, and then to make it into a no-code solution, it just became more difficult. But our goal here is to make all the connectors in no-code. We just want them, any new person comes in and says, I need a new source. And I say source, something like Google Ads, and some new company shows up as ads. We don't want them to code all the connector. We just want them to walk through the UI, give us the API. We hit something, we write the whole code, and we generate everything for you. So the goal is that's where we have built something called Connector Development Kit, CDK, which I'll come probably end of this session, which is a wonderful thing, which I seriously love that, because you just have to spend probably an hour or so just get one source running. So that's our goal, is to get it to 7 minutes, but yeah, we are pretty far from it, but I think we're going to be there soon. Frontend is more a solid choice of React because it gave us the comfort of being it more simple, and we don't do the front end. We have different people who work on it, but Java is mainly a conscious call because the whole team loves Java, and they have coded in Java for probably a decade or more than that. So that's the whole reason why we went with Java. It was more of a comfort and just getting it production ready right away, rather than seeing which is the right language, learn, and then hire people. So we are the best people, they know Java, and just we went for it. Okay, so here comes the serious component which the whole AirByte bets on. This doesn't run AirByte, it's not there. So worker is a responsible piece of the job. So what happens whenever you go in? Okay, I'm just gonna shift some time for the UI just so that everyone is comfortable with how it looks. I'm not sure if everyone had looked at AirByte, how the UI looks. That's how it looks. So you have majorly three options: source, destination, and a connection. So a connection is as I say, it's a connection between a source and destination. So you can create a bunch of connections by creating one source and one destination with a different configurations, or however you want, even if the same configuration works. So it's basically you have a source as an independent entity, you have a destination as an independent entity, and you can connect these two using something called connection. So all the status, all the frequency, everything lies with connection in terms of settings. So for example, don't mind the nonsense. I mean the names here. It's just a dev server. Yeah. So we have this as a source setting. Every source setting gets some details just to ensure that it has a right access to the API or to the database, whatever the source type is. So we have all the configurations. You can update it here in terms of password, and it's quite coupled with what kind of source it is. So we also support multiple types of authentication if there are any. Otherwise, it's more of source settings. And you will also find this is the connection settings. This is a common page you get for all the connections you set. So the name of the connector, the frequency, we have 5, 15, 30 to 24. You can set how frequent you want to run this connection for. Namespace configuration is more for database connectors to basically replicate which type of it. Mirror source structure is basically we have the source catalog, which basically defines what data you are actually pulling. For example, if you want to pull a table from Postgres, the catalog includes the whole table configuration on what column names and what type it is and etc. So these I'm showing you, this is what I think Google Ads connector. No, this is Shopify connector. So basically, if it's an API based connector, we show what all the data you can pull from multiple APIs. If it's a database connector, you get to see all the tables here, which are part of that specific database. So you can choose which table you want to pull. If it's a database connector, you can choose which API or which kind of stream you want to pull if it's an API based connector. So it's basically a place where you can choose what you want to pull. It's possible that you have hundreds of tables and you want to only pull 2 tables. It can be done. It's possible that you have just 2 tables, but you want different configuration. Yes, that also can be done. So there is one couple thing which we have here is normalization. So normalization is basically we store everything in a raw JSON string format in the database. So when you connect a destination, we have a bunch of destinations. We have BigQuery, Snowflake, Postgres, MySQL, and a lot of destinations. So whenever you connect to a destination, we store things in a JSON string format. We have something called raw tables where we store all of this data. And then if you choose normalization, that's basic normalization, then we convert all this JSON format, string format JSON into basically a table structure, and we normalize all the values there. So we create one more table, just not the raw table, and we normalize it. You also have one more option of creating custom DBT. So DBT is what we use internally to do normalization because it itself is completely decoupled. We run it in a separate space. It's not coupled with the connector code. So it gives us the comfort of transforming data, which we get in raw format for all the sources, to keep in a structured format, because we didn't want a connector to handle all these things, because we could keep, be it any source, be it an API-based source, database-based source, anything of that sort, we have a specific format of returning it out. So it basically returns the JSON structure, and we keep the raw in a similar format, and then we use DBT to transform it. And we also give the person using it a custom transformation where you can transform it in a way you want. You have to just give a GitHub repo for it. So that should give you a comfort of running your own transformation in however you want the table to be. So you can always stop me if things feel complicated in terms of terms. Yeah. And this is a page where you actually see all the things which run at what time, and we have a log which shows up the basic log information. If it's an error, we use this log to debug it. Also, you can see the normalization part, how the normalization is happening and things like that. So it's majorly a categorization of info, error, then bunch of other logs so that it helps in both the ways. Yeah, I think this is pretty much the UI. I think now it should feel a bit more close. So getting back to what worker is, so whenever I hit, okay, I think I missed one more. I came here to show you the sync now button. So you can actually initiate a manual sync for every connection. You just have to press the sync now button. So I'll not go into more of the frequency, but for example, if you're triggering a manual connection and if you're hitting sync now button, so what's going to happen is what we'll discuss now. So when you hit a sync now button, the API is sent to the server, API server, and it's going to hit sync scheduler to initiate the sync for this respective connection. So that's when we actually create a worker. So worker's duty is to make sure that the job which you're running is taken care of in these 4 ways. So first job for worker is to, we are a fan of Docker, I think. The first thing I should be mentioning. Reason being it's pretty decoupled in terms of how the sources run, how the destinations run, and everything has its own individual failure and nothing is failed when specific thing is failed, as the Docker says. So the goal of the worker is to initiate a Docker container. I mean, it's different for K8s, but just going with Docker because it's easy to probably explain and understand. So we have a scheduler container which runs, and the scheduler is going to initiate a worker. And this worker's duty is to create a source container, which the duty of the source container is to pull the data from your source, be it database, be it API, and it's going to it's going to write a standard out all the data which is going to pull, and the worker is going to read all the data which is standard out, and then it's going to send it to the destination container, which is also created at the same time when the sync has started. So all this data, whichever is given out by source, it has mainly, I would say, 2 types. One is the record. Basically, that's the data you're pulling from your source. The other one is the state. So if we have something called incremental connection, that means you're going to pull it every day. So we store the state once the sync is done. So the worker's duty is to take the state, process it, and save in our database, and send all the records to the destination. So that's basically standard out and standard in. And once the whole sync is done, source is successful, destination is successful, it's going to exit both of these containers, kill the containers, and then whatever the status it gets is transferred back to the config API server also, I think.
Harshith,
any questions here?
Yeah, I have a couple of questions. So when you mentioned that it saves the state, what does state mean? Is it like a date or like the timestamp from the database?
So I think we have, so it depends on the source. So the configuration of the state lies with the source. Most of the time it's going to be date. Because for example, if you're running Google Ads, you pull till yesterday, you're going to save the state as yesterday. And when you come in today, we pass the state object back to the source whenever it's created. So this source understands that it has to pull from the start. So it is state here. It's also possible that it's an ID. It's also possible that something else, but yeah, it's up to the source, how the sources are configured.
And in this incremental capture of data, does it like, so I think in a way, does it support sort of CDC?
Yeah, we have for databases with support. Yes, we do it. Like Postgres and MySQL. Yeah, we do it.
Yeah. Okay. Thank you.
Yeah. I find Worker more complex because it's more like a responsibility. I think out of all these pieces, one thing goes down, probably things can survive, but Worker goes down, things are at a different scale of loss. So that's the responsibility Worker has. So, and it's a complex structure which we have, but I think this is for how much we can go, keeping it more decoupled. But I like this. I mean, this is the simplest thing we could do here. This is basically a state machine of, yeah, sorry.
We just had another quick question jump in there. Someone's asked, does AirByte support streaming, or is it more scheduled and batch orientated for processing?
Streaming is something which is we have in 2022 second quarter. So we are working on it, but we don't have a solid answer right now because
Yep. So it's on the roadmap. It's
a bit
something
more,
that's coming.
Yeah, it's on the road. Yeah, I can say that.
Okay.
So this is majorly how the state changes for a job. So whenever you initiate a job, whenever you click on sync now, it's going to go into a pending state, which means we pushed it to a queue. It's not necessary that it has to be taken right away, because based on the resource constraint, we try to pick it once the resources are free. So right now, if you take, to give a good example, if you take an EC2 container of T3 medium, you have 6 to 7 jobs running parallelly. So, I mean, if you see that way, the queue can be having 100, but 6 only can run at a time. But you increase it, it's going to increase. Solution is KX, and I'm just trying to give you how the queue works here. So the pending state is going to move into running state once the job is picked out from the queue. And then all the process worker does is creating source, destination, and take care of all this thing. And then we're gonna say whether it's successful, failed, or cancelled. So cancel is you have to cancel it either through the API which we have, or you have to do it manually through the UI. But success and failure are the major jobs you see. So once it's successful, we check the repo, we send it if it's successful. Same with the fail. But there are some cases specifically. For example, you have done this for the first time, the source and destination are created and the connection is created. So if it's failed, we try it one more time, just to ensure that we are not missing something. And also you will see that we have good enough of retry mechanism. So once it fails, we're gonna retry the attempt 3 times. And the third time, if it fails, that's when we send the error notification. So we have a retry mechanism, and yeah, in the latest versions, you can configure it. You can say how many times you want to retry. You can keep it 1, 3, 10. It's basically a variable you pass. So that should be, that was the easiest thing we could do. Yeah. I think, yeah, there is good amount of jobs data we have. I can walk you through this URL. I mean, we have a lot of doc. I think nothing here is something which I just picked, but just collated a bunch of information from our docs. We try to keep the doc as much informative as possible, because being an open source, we want people to find answers in the documentation rather than every time coming in asking the dev. So you have more details and info here. I can also share the stock URL. Wait. Yeah. Why do I not see? Yeah, I've shared it in the chat.
I have a political question, Harshith. What is because AirByte is fairly new recently. So what was the motivation behind this? Because there are, some tools already in the market. So what is it that, what was the motivation behind this?
I think to talk about the tools which are there, we had two major I wouldn't say competition, but the two tools which occupy the space are Singer, and above Singer you had 2 more tools. Stitch was building Singers, a lot of things, and then Meltano was working on Singer. But we feel the way Singer runs is more, it doesn't have a good structure in terms of how you can implement, and because of which a lot of connectors go into a stale state. Like you see, for example, the WooCommerce connector is not even picked for the last 3 years, and there are so many connectors and of that sort, because we were not able to make it more simpler on how the connector can be built, and we were not able to really build a good community in terms of that. And I think that gave us a thought on the open source community of ELT is still left in an empty space. You don't have anything structured, and there were thousands of sources which were there. But if you look at the stat, we had only connectors at max, including all the sources, to be about 800. But believe me, there are so many companies which had APIs, and a lot of people want to use it. So we wanted to solve the long tail of the connectors. So we wanted to build a solid system, a development kit, which can make building connectors very simple, so that we can address a lot of sources where, I mean, that's end of the day is what community would need, making it simple for them to build and having everything whatever that's needed. So that's the thought process we had. Yeah, it did work out. So we're happy about the thought process.
Thank you. Yeah.
Yeah.
I think we have one more question in the chat from Shivesh. How AirByte differs from Airflow working mechanism wise, performance wise?
I think we are both in a two different space. AirByte and Airflow are not versus. We do have a very good blog on how we want to use AirByte with Airflow. So Airflow is more of an orchestration. We expertise in ETL pipelines, how we want to pull the data and how do we want to build the source and destination. So our expertise is in pulling the data of the source and destinations and the process of it. So you Airflow gives you the comfort of how do you want to pull it, making it more easy in terms of managing all of these things, and we're totally happy to address that. That's the reason we have been working very close with Airflow on making it more simpler to use with it and for a bigger scale of companies. But I think both are in different space in itself, so I don't think it makes more sense to give performance wise. Mechanism wise is what I can answer. That's the thing. We have our expertise is in pulling the data from a lot of sources and addressing the longest tail. So that's probably the major difference. Is anyone more curious about something else in the demo? I can just walk you through a bunch of tabs. So all of our sources are Docker based. So we have every source as an image and has a version tagged with it. So to make the development process more simple. And if you want to get back to a version, you can happily get back to a specific version. And if you don't want to update it, you can also do the same. So you can update all your sources versions here, and you can also add a new source, new connector. You can build your own connectors when you work at a bigger company where you don't want to share your source code and it's probably only specific to you. So then you can still build custom connector and you can make an image out of it and then use it back here by adding it as a custom connector. Same goes with destination. You can also add a custom connector as a destination and use it. So we both support both of these features here. And we have a long tail of connectors available for destinations right now. You can export the whole config and import in a different AirByte instance. So we don't have anything complex there, just to get a tar and you just upload the tar. So nothing of anything complex there. We give this logs for more support on the community. So you can always download logs here and share it if you have any troubleshoot. It's pretty easy to solve things if we have the logs, because all the pieces whichever we have a common logger which emits the same kind of information across the board. It's pretty structured and helps us answer and probably debug in a better way. I was also talking about webhook. You find it here. You can choose when you want to send the notifications. You can extend it to a different level in terms of if you want to run certain process after the sync is done. Yes, this helps. You get a notification to this webhook when it's success, so you can initiate certain process ensuring that this sync is successful. And the same, you can have a different retry mechanism if you want by using this webhook. You get a notification once it failed, and with the connection ID, so you can happily use it to do the later process and the later steps.
Harshith, I have another question. So all this deployment of AirByte can be done as infrastructure as a code?
We are working on a Terraform provider, which probably by end of this quarter you should have it. But something which we are very we are spending a lot of time on it. So we are seeing how easy we can make things there. But right now, I think our deployments are majorly on EC2, and it's. I mean, I understand that part, but it's also easy right now to deploy. It's just Docker Compose up, so that's where we got started. Because Terraform has a certain our update process is a bit complex in terms of doing it when it's an infrastructure. But obviously, that's an end goal because we want to give AirByte as also a service which they can run on their own system. So then it should be more helpful for us. Yeah, something which we are very closely looking. Happy to inform you back once that is up.
Yeah, thank you.
And we also have one. Yeah, Tim.
I was just going to add on to that. One of the bits that I like is that you can actually run it locally. I was able to turn around and just pull the containers down and run it on my laptop, which was nice to be able to sort of click around it and see what it's like and understand it and have a little bit of a look under the hood and that kind of stuff. So it's good that it supports all the major cloud providers and I can host it out on somebody else's infrastructure. But it's also good that you can still run it locally and everything as well. It's really good.
Yeah, I think we also have certain cloud sources which help one-click deployment. So we are really looking towards it. One good kickstart we had was DigitalOcean. So we started a open source droplet there, so you can always just go create one, select AirByte, and then install it. So we are working towards it where we can provide one-click deployments for Heroku is also one which we are working on. So yeah, I think we should be there sometime soon because we understand that you can't decide something without really experiencing it, and we want to make the experience process more smoother. Being happy to hear feedback on that. If anyone has something out of their mind that why don't we support this cloud, I think we should really pick it. I think there is one last thing. I'm not going to spend more time on it, but which I feel is more important, probably like a backbone of all what we do here, is the CDK. We got Connected Development Kit. We find like we want the whole development to be happening in a no-code solution. So that's the whole idea why we started this Connected Development Kit. This works for Python. We have actually two more. One is in TypeScript, the other one is C#, which been both the TypeScript and that are being contributed by an open source. But CDK of Python is something which we build internally, and we spend all of our time on it. So this is a complete CLI-based tool. So you just have to start. I think I can show the CLI. So we have something called generator, and you just have to go and do yarn generate. It's gonna ask you a bunch of options, whether what kind of source you wanna build, as it HTTP API, single source, or Java JDBC, generic source, and a couple of things. And if I say Python HTTP, just have to give what the name of the source. Let's say Google Ads, Google Ads 2 probably. And I think we generate the whole config on being the secrets, the secret file, which you can obviously replace it with your own secrets, and then the whole integration test. So to make things more simple, so we understand that writing test cases. So we actually turned the other way around. We wrote a bunch of test cases to ensure that the source is working rather than doing a lot of manual work. So once you write it, there is nothing stopping you. All you have to do is just post the integration test and we are done. We just merge it. So we keep it as simple as possible. So we do all this generation of all the files in one click, and then you'll have to just start changing it. We already have a lot of readmes there on how simple we can make it, and we also have a bunch of videos on how to make this work. But yeah, so this is something 40% going to try out. I think pretty much that's it, Tim. If anyone has questions, I'm happy to take.
Sure, thanks. That was really good. I learned a bit about it because as I said, I haven't spent a lot of time, but I'm really curious about it, and I think it's a really interesting space. Particularly as you pointed out, I personally sort of view it as being a little bit different to Airflow, where Airflow might enable you to turn around and build your custom DAGs and complex DAGs or whatever for your own pipelines. I hope that AirByte might be really useful for prescribed sources and destinations where you already know what they are, and you can just configure and use those things that are already there. So I think that's really exciting. One question I suppose just that came to mind was how many connectors does AirByte currently have? Does it have like 5 or 500 or?
We have a lot.
Had a lot.
Uh,
Great. Great. So they're all the things that we could potentially plug into. So if I was working for a company and we had data that was in BigQuery and Braintree, then we could use those connectors and just configure them and then automatically start to build those pipelines.
Yeah, I think our goal is to address 1,000 connectors by end of the year.
Wow.
So we are trying to be there. There will be a lot of connectors which are in alpha state, which pretty much didn't reach the dark state yet. We are testing it out. So yeah, we are working on that pretty hard.
Great. How would you compare, Duana's come up with a question, how would you compare AirByte to things like Kafka Connect? Kafka is a predominantly streaming platform. And it has a Connect framework, which I think aims to do similar things and provide easy connectivity and sourcing and syncing of data. Kafka.
I think
you compare that?
I think from my point of view, when I was using it, to address a very long tail of 1,000 connectors, we needed a standard process setup in terms of how generic you can make. What is that common in all of these connectors? Until we figured out this common part, it just becomes more complicated to manage all these 1,000 connectors. I mean, you have to constantly upgrade it, change the APIs and all. So unless we have a common structure and system set up there, it just becomes there is no point of addressing 1,000. Then you're just going to create once and then leave it. It just becomes single again. So I think the harder part here is to address that, and we have come up with the CDK to address it. So that would be a major difference, because this gives us the comfort to manage all of these 1,000 and maintain all of these, which is pretty difficult, and you find it very difficult if you go for other sources. It's not Kafka, you have Fivetran, you have Meltano, and a lot of these things. The biggest, hardest part is to maintain all of these, keep them updated every single time some change happens at the source. So I think that is the major difference.
Oh, great. Does anybody else have any other questions? I can't see anything else in the chat there. So again, thank you very much for sharing with us, and we'll reinforce that it is open source. We'll leave some links in the Meetup page if people want to go and download it and try it out for themselves. I joined the Slack channel, which I was really surprised about. It actually looks really active, and there's lots of good stuff happening in there. And it's a good place to ask questions and stuff if people want to learn more whilst they're testing it out and experimenting and stuff as well, I think. So I might just share my screen.
Oh, sorry, I have one more question. Do you mind?
Oh, sure, yes.
Yeah, thank you so much. This is great, having access to directly ask all the questions. I've worked with Kafka Connect before, and sometimes it's hard to do custom credential or authentication stuff, like if you're doing, something specific or cross-cloud. How does your CDK maybe allow for these kind of customizations?
That's a very good question. I think the way we want to address it is, that's the reason why I keep config store as a separate store in itself. So we give the config as a input from the user. So if we keep the whole credential part in a different space in itself, the point where I'm getting is, we don't want, probably if someone wants it to use internally, connect some other secret store manager or some config store from AWS. Our goal is to reach there, if that was the question. But I think the end goal is there to use your own secret manager, and it's more like plug and play is what we want. Don't like couple it, completely couple it with the AirByte code. So we should be reaching there in next quarter. End of the next quarter is our goal. I think then everyone has the comfort of just connecting your connector store and just using it.
Yeah, thanks. Yeah, that makes sense.
Yeah, good questions too. So thank you very much to Harshith. Is that sharing? It says here sharing. Yep. So we'll step over to the marketplace, as this is a great opportunity if anyone is perhaps looking for different sorts of work or opportunities, or looking for people to help in their organisation or projects. We'll give you 60 seconds to unmute yourself and address the community. There's only a few of us here and stuff, but feel free to talk freely. And if you have details about your project or a LinkedIn profile if you're looking for work, or a ad advertisement for a position or a role if you're looking for stuff, then you can feel free to share that sort of stuff on the Meetup page itself afterwards, so that people can find it and it's accessible and get in touch with you about your projects or opportunities and so on and so forth. So does anyone have anything they want to share in the marketplace? No. No? Okay. Well, thank you all very much, and thank you to Harshith for our presentation on AirByte. A special thanks as well to ThoughtWorks, who helped provide the Zoom link and stuff. It's been really great all year, and I can't recall ever having a problem with it before, so I will treat the little issue we had tonight as an exception, but a huge thanks to ThoughtWorks, because it makes it easier to run these events when everything works. So the next meetup, as I alluded to at the beginning, will be in January next year. So it'll be the last Thursday in January. We won't do a December meetup because we think everyone would be too busy partying and having too much fun and on holidays than to be worried about data engineering. The organisers' details are there. So Andrew, Harmeet and myself are there. So if you have any questions or want to talk about some specific topics or technologies or tools, feel free to reach out to any of us, and we'll see what we can do about helping to organise that sort of stuff. Or if you've got something that you want to talk about as well, that'd be fantastic. We'd love to hear more people in the Melbourne community sharing about tools and technologies and their experience with data engineering. So with that, I think we will close things off, but thanks again to everybody, and we look forward to giving you an update in January.
Thank you. Thanks, Harshith. That was really useful. Yeah.
Thank you.
Thanks, everyone. Thanks, audiences as well. Thanks, Tim.
Thanks.
See ya.
See ya.